Hi, I'm Jonathan Oxer, and this is SuperHouse. In the last episode, I said that I'd give you a quick tour of the automation switchboards around the house so that you can see the actual physical side of what I'm doing, not just stuff on a whiteboard. And I'll do that in just a second, but first, there were a couple of comments after the last video with some really good questions from Alan Garfield, and he was talking about alternative ways to do it, basically questioning why I would bother cabling all of the loads all the way back to central points rather than distributing some of the intelligence. So the alternative way of doing this is that you leave the existing hop-to-hop, point-to-point cabling in place. So you have power going through to each of the loads on a single or a couple of circuits like you normally would. But what you do is place at the load itself some kind of a device that can turn it on or off and that you can communicate with. So the reason for that is that it means that you use a lot less cable. Obviously, we don't have to have a cable running all the way back to the switchboard for every single thing we want to switch. Now, there are upsides and downsides, and which way you go really depends on a number of factors, like whether you're doing a retrofit. If you're doing a new build, then it's a lot easier to run cable through framework when there's no plaster on the walls and insulation isn't getting in the way and things like that. So you save big on labour doing it for a new build compared to doing it for retrofitting, because if you've got to get it through old walls, drilling down from inside the ceiling space and things like that, you can burn a lot of time, which is money, of course, if you're paying an electrician to do that sort of thing. So it comes down to a bit of a trade-off. There are technical issues and there are financial issues. Now imagine that you're in my scenario. You have open frame and you can run cable from the switchboard to every load individually. What that means is that you use a lot more cable, because just using round numbers, imagine your cable costs $1 a metre for heavy gauge mains cable, so 2 core plus earth sort of thing. And your electrician probably costs more than this, but for round figures, once again, say $60 an hour, so $1 a minute. So you're up for $1 a metre for cable, $1 a minute for time. And it might take 20 metres of cable to get a cable from the switchboard back to a light in the house, and electrician's time to drag it through the wall. So you're up for $40 roundabout to run that cable through to that load. So the alternative way of doing it, which is what Alan was questioning, is use a much smaller amount of cable. It means that you save on the raw material costs, probably save a bit on the time costs as well, because you don't have to drag the cable all the way through for every light. But instead you place some intelligence at the endpoints. And that could be an Arduino type device, or it could be a fairly dumb device. You could even do something like, in a really crude approach, what you do is put a relay at the endpoint and run some kind of like a low power switching wire through to it, and you just fire the relay and away you go. So you're up for a little bit of cost at each of the endpoints. So what it comes down to is a trade-off of the cost of the cable versus the cost of distributing the intelligence. So I don't need to have, with this approach, which is like an octopus sort of approach or a star approach, I don't need to have much intelligence at each of the endpoints. The lights themselves are just a light on the end of the cable. If you need to switch it using some kind of device, you need to put something there. If you can budget $30 or $20 or something like that for some kind of a receiver and a switching device at the end, you may end up ahead doing it that way. There are some technical issues with it. One of the issues is how you communicate with that device. There are really 3 different approaches. One is to run a separate signaling wire, so some kind of communications network, which could be Ethernet, which is kind of heavyweight for this sort of thing, but you can use that. It could be RS485, like serial comms, but basically you still need to get a wire there. Another way is to do it using wireless. So something like, in Australia, you'd probably use something like 433 megahertz communication. Personally, for a fixed installation like this, I don't really like wireless. I'd rather go cabled. And the third approach is signaling over the power line itself, where the device itself is connected to the power line. You have a controller at the other end, and as well as the mains, so the 240 volt, or if you're in the US 110 volt, that goes across the power, you also have some kind of a control signal modulated onto that using AC coupling or something. And that's how EtherTen works, for example. You put a device out on the end and you send a signal and it turns the device on, which switches through the power. The end result of all of this is I don't like the idea of distributed devices, which are complicated, potential point of failure. I'd rather have everything centralized in terms of switching rather than having little things scattered all over the place. So what I have is in terms of the high voltage switching, a very centralized approach, which yes does give you a single point of failure. So there are always trade-offs with this sort of thing. But what I've got is all of my switching in one location, well, two locations, but in a very nicely defined point. It's in a clean environment, it's easy to maintain, easy to get access to. Don't have to go crawling through the roof or something or try to fish, some kind of a receiver out of the wall if something goes wrong. So this is the particular approach I've gone with. It's a bit of a judgment call. It's whatever works best in your situation. For me, this worked well. Now, boring bit, but important, starting with the paperwork. Inside the switchboard is a clipboard with a whole bunch of information in it. So this includes, on the front page, details of our electrician, contact details. The whole point of this is that automation systems are generally reasonably non-standard. They've got lots of twists to them. If something goes wrong and I'm not around and we need to get an electrician in, it's okay phoning an electrician and saying, come down and help us fix it. But if they open it up and look at it and go, what the hell is this? How do I find anything? Then it's not so good. So this documents the location. There's a little map of the house. It documents the locations of all of the switchboards in the house. It shows the demarcation point, so what's cabled to where. There's a data labeling scheme for all of the data cables. It lists every single Ethernet termination point, the ID on the patch panel that you'll see in a second, the location of the termination point, the purpose of it, like it's got notes as to whether it's terminated, whether it's got a camera fitted to it or whatever. Goes on for pages and pages because there's a lot of Ethernet in this place. And then it goes into power circuits. So it's got the identification system for the power circuits. All of those are labeled. And then it lists every circuit and it shows what output channel each one is connected to, which of the automation controllers. So if anything goes wrong, the idea is you can walk up to the switchboard, grab this, and within a minute or two of flipping through it, you can orient yourself and know where to find stuff if you need to. So that's pretty important. A lot of people jump into just putting stuff together without really any consideration for maintenance, and it can really bite you later if you're not careful about it. So make sure you document things. Documenting and labeling is really important. And the way I work this, so this is a printed document. The original is a Google Doc. So what I do is I have hard copies of this at both ends of the house, in the switchboards at the two ends of the house. And whenever anything is connected up or changed, I just handwrite into this. And then periodically I go back, update the Google Doc, print new copies and stick them back in there. So you can update things as you go, but still get the benefit of the dynamic document. So let's see what else we have in here. Right up the top is a monitor, which is just sitting on a mount, jammed up into the top corner. And this is showing, at the moment, it's just showing a tail of a log file, which is out of the control logic. So if any of the buttons are pressed, you can keep an eye on it there. It shows you the events. Normally there's other stuff up on the screen, but that's kind of confidential. So for now, this is a sanitized version, just shows some of the events that have taken place. Just below that is the automation switchboard, and we'll have a detailed look in that in a moment. You'll see that it's marked BA, that's part of the labeling scheme here. So B is the identifier for the telecommunications space, it's switchboard A in space B. So there's a hierarchical naming scheme that goes from the telecommunications space down to the items within it, and then from there to individual channels and circuits and cables and so on. So the idea is that you can grab any cable and know exactly where it's terminated at both ends. And this is the bit you've been waiting for, what this episode is all about, inside the switchboard itself. So it looks pretty normal. Other than the fact that it's a lot bigger than your typical domestic switchboard, a lot of the time switchboards in houses are about this big. They've got maybe 1 or 2 rows of circuits on them. This one's very tall and doesn't look like there's a lot exposed because we've got circuit breakers across the top and all of the other interesting stuff is inside. So let's have a look. So we've got the circuit breakers, which are pretty normal, nothing unusual about that. Earth leakage circuit breakers. Up in the top right corner you can see a really big bundle of cable. And the reason for that big bundle is, as you can see, we've got cables going out to all of the loads in the house. So we've got bathroom light, you can see it says B3 wall and master and various other things. So each of those cables is labelled. Down here, this is the interesting bit, we have a bunch of relays which are on DIN rail mounts. And these are mains rated relays, so they are switching the output loads. And on the input side, obviously it's low voltage. Now down in the bottom left of the switchboard here you can see an Arduino compatible board, that's an EtherTen down the back there, with onboard Ethernet. And it doesn't have power coming into it directly because it's running power over Ethernet on this network cable. So we have the network cable coming into the back of the switchboard, and essentially what this does is give the switchboard a web interface. So using a web browser we can connect to this interface and we can click on buttons on the browser that turn different output channels on or off. And as I was explaining in the last video, that's essentially how we communicate with the switchboard at the moment. We do HTTP post to send values to this, telling it which channels we want to turn on or off. Now as you can see, this is not final. This is pretty messy and it has a couple of problems. First is that we need to make sure that all of the wiring within the switchboard itself is 240 volt rated and it meets the fire standards on the insulation and various other things. So I have some PCBs on the way. We've designed up a little output channel, like a multi-channel output driver, which is actually going to be a new product for Freetronics. But I designed it because I needed it myself and I figured other people might like it too. So it's just one of those things. Design for yourself and hopefully other people will find it useful. So what that'll do is provide a really nice, properly isolated output control PCB, output control shield, and I can stack a couple of those in there and then use mains rated cable and everything to control the relays and everything will be fine. At the moment though, this is just a temporary thing hooked up so I can prove that this works, and it'll be replaced very soon. Down below that switchboard is a whole lot of mess, and so we've got broadband internet connection, this is our firewall, there's an Ethernet switch, this is the EEE box which is currently running the web interface for the automation system and providing all of the logic. Down here you can see a whole bunch of Cat6 cables coming in and another Ethernet switch. This is all a bit of a mess, and a whole bunch of plug packs. That's all pretty ugly. And right down the bottom is the UPS that has been flooded a couple of times, which you would have seen if you've watched my walk time blog. And down here we have some power over Ethernet injectors. What these are doing is sending power down the network cable to devices at endpoints like control surfaces. So as you can see, it is a mess. We've got these patch panels that are currently either sitting, a couple of them are screwed into bits of timber, so they're not in proper racks yet. So the next thing I've got to do is pull all of this out. I've got to take out these old bits of timber and mount some 19-inch server rack in here and fit everything back in nicely so that it's all secure and neat. So down here I've got some old bits of server rack. This was actually all originally the same rack. It's one that I bought I think about 20 years ago from a metal recycling place that was getting rid of a whole bunch of medical equipment. Originally this had medical computers or gear or something in it, and they were selling it out of scrap metal, so I grabbed a few of these. And it was originally double-sided. What I've done is sliced it in half vertically, which gave me two single-sided racks, which I used for quite a few years. And just a couple of days ago, I took one of those halves. You can see the two bits here. This was previously the front of the rack. Sliced that in half, and that has left me with this bit of rack, which I'm going to use in this switchboard, and this bit of rack, which I'm going to use in the other automation switchboard at the other end of the house. I've had a bit of a go at cleaning this up with a wire brush, but I haven't been able to get all the paint off it. Many years ago I sprayed these black because I thought it looked cool, but the problem is the black sort of scrapes off and it gets everywhere and it's really yucky. So now I just want to polish it up back to its original metal condition. So I think I'm going to have to hit that with a wire brush and a drill, otherwise I'm never going to get the last little bits of this off. Let's give that a go. Okay, so now we have a nicely cleaned up bit of server rack. It's really strong, it's good steel stuff, and it's going to sit straight back from the position that it's in right now. However, we've got the UPS to deal with down the bottom, and I want to be able to have something for that to sit on, and the frame in this gets in the way. So what I'm going to do now is measure up for a timber base that I'm going to make that will sit on top of this frame, and the UPS can then sit on top of that, and that way there'll be a good strong flat base to work from. So let's do that now. Nice tight fit, looks good. Now it's time to try to get the rack into place. I've cleared it out as best I can. My intention here is to try to get the rack in without shutting everything down, which is going to be a bit of a juggle, but I may be able to pull it off. Well, I did manage to get the rack in without shutting everything down, but the cabling was still a bit of a mess. So I ended up taking the house offline for about 4 or 5 hours today, disconnected everything and ran all the cables back through, tried to get everything neat. And it looks a lot better now, so take a look. Starting from the top of this cabling area, you can see that things are a bit neater up here. Firstly, one of the old 8-port switches that was hanging on the wall here is just totally gone. You'll also notice that the cabling has been neatened up a bit here. What I did was put a phone patch panel directly on the wall there, and I crimped up a special little RJ11 cable to connect straight into the modem, so that's nice and neat. And as you can see, stuff is labelled. That's really important. I hate it when I'm looking at plug packs or something like that and I can't figure out what something is connected to. So I've gone a bit crazy with the label writer, put labels on everything and on the cables and on the plug packs and even on the power cable, so when you're looking at the other end of the cable you know what it's connected to. Shouldn't ever be a situation where you grab a cable and you don't know what it's for. Still got the EEE box underneath it, which is running Apache and PHP, and it's running one of the MQTT servers. And what was previously connected into the switch over here now connects to a rack mount switch. So everything is now terminated on these 3 patch panels. The top 2 are both Cat6 patch panels, so theoretically up to 10 gigabit Ethernet. These ones are used for PCs, like computer type devices around the house, not home automation type thing. So these go through to patch panels in this part of the house. There's a 10100 switch here, which is probably fairly temporary. And down the bottom, this is the patch panel for the automation networks. That's all Cat5e, but that's going to things like Arduinos mounted around the place and different bits and pieces. And now, what you'll see in the front here are a couple of power over Ethernet mid-span injectors. And what these do is sit in between the switch and the patch panel, and they allow you to send power down the Ethernet cable so that devices at the other end can be powered straight off the network cable rather than having to have their own local power supply. I'm going to give you a better explanation of that next time. And down the bottom is the UPS. It's now sitting well off the ground. There is a power board, as you can see, lots of labels on everything, labels on the power board ports, labels on the cables, so no doubt about anything where it should go. Some of the cabling is also being concealed. This green cable, for example, used to just hang straight down inside here. It goes to a Wi-Fi access point, which is mounted up in the top. Now it goes in through the back of this and travels up inside, so it's much clearer in here, much neater. Oh yeah, and also something else that I should have pointed out earlier. The back of this whole cupboard is 19mm chipboard, so it's floor sheeting. It's not just plaster. And the reason for that is I wanted a good solid back that I could screw things onto and have electrical isolation as well. And also behind here there is a lot of power because we've got the switchboard itself mounted higher up. We've got all these data cables and we need complete isolation between them. So there is a stud that runs up directly between them here, and all of the power inside the wall is on the right, all of the data inside the wall is on the left, and they are physically isolated. There's no way those cables can come in contact with each other. So we have total isolation between the data and the power side of the network. So it still looks a bit of a mess because we've got these mid-span injectors hanging out the front here, but that is going to be cleaned up. That's going to be the next project. Overall though, it still looks a lot more maintainable than it did before and much easier to understand what's going on. So as you can see, things are a lot neater now. But how does Power over Ethernet work? That's really one of the fundamental parts of the system, and it's a really handy thing to understand. So in the next video, I'm going to give you an introduction to Power over Ethernet, both the DIY version, which is what I've got running here right now, and I'm going to show you how I'm going to upgrade this and replace it all with commercial Power over Ethernet. See you then.